Hello guys, a very good evening. Welcome back to my YouTube channel. Today we are learning the third part of the load calculation sheet. Very important it is. Why? Because in previous slides we have just seen the basic terms and terminologies that we use in a load calculation. But in today's topic actually we are entering the load calculation procedure. Okay. Let me start with the seventh subtopic, that is load calculation procedure. You can see 9 steps are there to finish the load calculation. See one by one. Step 1 is list all your loads with the quantity and rating. Okay, if suppose you are doing it for 1 BHK home, you will get what? You will have light points, fan, fridge, right? Then micro oven. So you just have to list down the quantities or the equipments with their wattage rating. If you take LED watt, it will be of 8 or 10. You will need to check that one. So you will get the wattage of all the equipments, right? Then step 2 will be calculate connected load. You will get first, you will do it for light, you will do it for fan, next for other equipments. Sum the all the quantities kilowatt, so you will get connected load. The next step will be the converting that connected load into demand load. Why? Because you always load the transformer on the basis of demand load, not on the kilowatt, not on the connected load, right? How do you convert? Maximum demand is equal to connected load into diversity factor. Why? Because the diversity factor is the connected load divided by maximum demand, right? That is in it always be greater than 1. In case of if you are mentioning it in percentage, how will be the connection? How will be the formula? That is maximum demand is equal to connected load into diversity factor, right? The next step will be adding 20 to 25% spare capacity. Why? Because in future if you extend some equipment, so on for the safety purpose, you are adding 20 to 25% spare capacity. Always you have to add for wherever you go in electrical system design, you have to add 20 to 25% spare for everything, not only the transformer loading or anything. For everything you have to do. Even on doing the cable sizing also you have to give the spare. Then fifth step will be you will get all the load in kilowatt, but all the transformers or DGs are they are rated with a kVA, not with a kilowatt. So you have to convert that kilowatt into kVA. How do you convert? kVA is equal to kilowatt divided by power factor, right? Then you will get the kVA. Then suppose you will get with the 580 kilowatt, 580 kVA you will get, but standard transformer is not available with that value, so you have to go for next size, higher size. So next transformer size is 625 kVA. Your result is 580 kVA, but you don't get that 580 kVA as a standard transformer with any manufacturers. So you will go with a 625 kVA transformer. Same you have to do it for DG or panels, cables, everything. Then you have to while selecting the cable, very important factor is considering the voltage drop and short circuit. That we will see in upcoming videos in detail about these two topics. Then step 8, design earthing and lightning protection. These two are very important factors in electrical system design for human safety as well as equipment safety. Step 9 will be the finalize your SLD and BOQ. This is about 7th topic. If you see about 8th topic, same procedure but with example it is explained here. Actual example I have taken for residential LED lights. 30 numbers are there, each of 15 watts, so you will have total watt is 450. Like for fans, sockets, AC, yeah, then geyser, kitchen and other equipments. So you will get all the connected load right here. Then convert that into maximum demand by applying diversity factor of 0.7. That 0.7 value also I have already explained about this value in previous videos. Please go through it. Okay. 25 kVA transformer you will get. Again you have to add 20% spare for that. See, now your kilowatt is 16.24. We will convert that into kVA, then add 20% to that. Right? Then same thing is done for commercial here. You please go through it, but for commercial it is not the case because so many equipment, so many points, like point, fan point, not fan, like so many equipments will be there. It's not a common one flat, right? 1 BHK flat or 2 BHK flat. So it is so big. You will not do as you done in previous slide. So what you will do? You will follow one local procedure that this much of wattage you have to consider for this much of area. Suppose the office building is 50,000 square feet, right? Now you are assuming that you are taking for every 1 square feet you are taking 4 watt. So this 4 watt per square feet, it's totally depend on your local guidelines. Same thing I have done it for one of the project that is located in Mumbai. There, according to that MSc DCL regulations, it's the local regulations. For commercial, we have to take 150 watt per square meter, right? Without AC it is actually. If you consider AC with the load, that is 200 watt per square meter. For residential, it is 75 watt per square feet. Actually, it is the best procedure to follow. Why? Because you can reduce your timings and you can get easily, right? Connected load you will get, because total you have 4 watt per square feet, but now you have 50,000 square feet, right? 50,000 into 4 you will get. For 1 square feet it is 4. For 50,000 into 4, 200 kilowatt you will get, right? Then diversity factor will apply 0.8. Maximum demand you will get, add 20%. Then kVA, select the transformer, right? Then the next topic is current calculation formula. Now you end with the kVA, right? The transformer and all. Now your next duty is to select the cable size. How do you select? You will select on the basis of current, right? Suppose your kilowatt is this much, your current requirement is 25 ampere, and that basis you will select the standard cable. Appropriate cable you have to select. So for that reason, first you will calculate the current. How you will calculate? The very basic formula in electrical system, that is P is equal to VI cos phi. This is for single phase, and for 3 phase it is P is equal to root 3 VI cos phi. For that, from that formula you will derive one more formula for current, that is I is equal to P divided by V into power factor. For 3 phase it is I is equal to P divided by root 3 into V into power factor, right? Then voltage drop, how do you calculate for single phase? 2 into L into I into R divided by 1000. Usually this voltage drop, how do you calculate V? We will calculate using I into R only, right? I into R. That L is how long that cable is running. That is the length of the cable. Why the 2? Why? Because you will have in single phase, you will have two lines. One is phase and one is neutral. So that's why it is multiplied with the 2 and divided by 1000. Why? Tell me the answer. Then same for 3 phase, it is instead of 2 you are writing root 3 L into I into R divided by 1000. Example you can see for single phase, P is equal to 5000 here, V is equal to 230, power factor is equal to 0.9. So by applying the single phase formula I will get 24.15 ampere. Okay. Then next topic is power and kVAR formula. How do you convert kilowatt into kVA? What is the relationship between kilowatt and kVA? That you will get in this slide. Very basic formula that, and very basic terms in electrical system we have, that is real power, reactive power and apparent power. Okay, real power meaning what? The actual power you are going to consume. That means the actual power your equipments are going to consume, like light or something. But light, fan, how much they will consume, no, that is reactive power. But reactive power is, suppose you are a source, you are sending 10 suppose 10 chocolates you take, 10 chocolates will send. Out of 10, only 9 are received by the receiver at the end of some distance, and 1 will be lost in the middle. That loss item is reactive power actually. The 9 chocolates you will get at the end, that is real power. The combination of real and reactive is apparent. The total amount you sent. Got it? This is very basic. Kilowatt P is equal to root 3 VI cos phi here. Then kVA, it's simple. Usually, how can I say, kilowatt means root 3 VI. That's it. If you multiply that with power factor, you will get, actually kVA, kVA is equal to root 3 VI. If you multiply that with power factor, you will get kilowatt. So by reversing, you will get kVA. kVAR is equal to kVA, that is root 3 VI into cos phi you will get. But sign of cos inverse of phi. Don't get confused. kVA is equal to root 3 VI. If you multiply that with power factor, you will get kilowatt. And kVAR will be kVA. There in kilowatt you will get kVA into cos phi. Here kVA into sine of cos inverse phi. Phi. kVA triangle. I have already told you that kVA is the apparent power. It's the total sum of kilowatt and kVA. The formula will be kVA square, or kVA is equal to square root of kilowatt square plus kVAR square. Okay. Then lighting power factor will be 0.95 to 1, and the motor's power factor will be 0.75, 0.85. AC or HVAC will be 0.82, 0.9. Mixed load 0.85 to 0.95. This is about the relationship between kVA and kilowatt or kVAR. This is all about this part. Next, in upcoming video we can start with some more topics. Please go through this video, and if you find any difficulties, please do comment in the comment section. I will give you the answer. Thank you for the time. Please do subscribe to my YouTube channel, share your ideas, share to someone. It may useful for them also. Please give like and share.